Good morning, everyone. We're going to continue on with simplifying rational expressions, but this time we are adding and subtracting those rational expressions when they don't have the same denominators. So if you need to recap, please watch my previous video over adding, subtracting rational expressions with like denominators. So first we're going to review adding, subtracting fractions when they don't have the same denominator. And that means we're going to remember what a least common multiple is. So number 1 says 2/5, or 2 divided by 5, plus 7 over 20. And we need to make sure we have the same denominator. So we want to look for the least common denominator, so at least common multiple from these two, and that would be 20. So similar to GCF, but think of the multiples of. Okay, so know the least common denominator between both of these would be 20. Okay, and so that means we need to change this 5 to look like a 20. And in order to do that, we need to multiply the top and the bottom by 4. The top and the bottom by 4. So 2 times 4 makes this 8. The bottom is now 20 plus 7 over 20. Now they have the same denominator, so we can actually add across. Remember, when we're adding, we're going to keep the same denominator, which is 20. And then 8 plus 7 is 15. And then we reduce our fractions if necessary. 15 divided by 20 is 3/4. So now let's look at example 2. We have 3 divided by 4 minus 5 divided by 9 plus 2/3. So again, we need to figure out what the least common denominator is supposed to be. So between here, we have 4 and 9 and 3. And the least common multiple that they have in common is 36. Okay. Between 4 and 3 would be a 12. Well, because of this 9, we have 9. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. And so then we have 3 can go into 36, and so can 4. So LCD here would be 36. Okay. So that means we need to change all of these to make sure they have the same denominator. So in order to change 4 into a 36, we need to multiply it by 9. And so we got to do the top by 9. For this next one, we have 5 over 9. We need to change this 9 to a 36, so we need to multiply it by 4. And then for 2/3, we need to change 3 into a 36, and that means we need to multiply the top and the bottom by 12. Okay. So this means when we multiply that top and bottom by these numbers, 9 times 3 is 27, bottom's 36, minus 5 times 4 is 20, all over 36, plus 12 times 2 is 24, all over 36. And then we add and subtract like normal. So everything in the bottom is still 36. 27 minus 20, and then plus 24, that gives us 31. And we cannot reduce it, so this will be our final answer. Okay, now let's do finding the least common denominator just for these next few problems. We're not simplifying, we're not adding, subtracting, just finding the least common denominator that they have. So for this one, we have 4 and 2 and 8. So think about just doing the LCD for those numbers. So we would have 4, 2, and 8. And the LCD for all of these would be an 8. Okay. So we know 8 would be part of it. Then we have x squared, x, and x. Well, GCF, we would take the smallest out of the two, so we think greatest common factor would be x, but we want the least common denominator, which means we have to multiply to make sure that they all match. So I can't really take away an x from 4x squared, but I can multiply by x to get x squared for 2x and 8x. So x squared and x would be x squared, and so 8x squared would be our least common denominator. Let's do the same thing for number 4. We're not changing these. Again, we are only finding the least common denominator. So denominator is your bottom parts of your fraction. So we're going to talk about 8, 5, and 4. And between 8, 5, and 4, it's actually going to be 40 because 4 times 10 is 40. And then we have times 8 and then times 5 for 85. So it would be 40 here. Then we have xy squared, x squared y, and then we have x. So from here, we know we need to have the same number of variables. Exponents have to be the same. So for this one, for x's, we know they need to have x squared. So x squared, and x, very similar to this one, we know we need to use x squared. Then we have y squared and a y. And even though this one has no y's left, we know they have to at least have two of them. So x squared, y squared. So 40 x squared, y squared would be our LCD. Okay, so now we have 5 over x, and then 3 over 2x. So this time we have an exponent, the coefficient of 1 and 2, and the least common denominator here would be 2, because I can multiply this one by 2 to get the same one. Then we have x and x. Well, they will have the same denominator here, so it would just be x, or LCD here would be 2x. Okay. Now for our polynomials. So again, they have to have the same LCD, so we may need to multiply top and bottom by a monomial or a binomial. So we have x plus 1 and x minus 2. Again, they have to have the same denominators. If I were to add these together, they have to have the same thing. So this one would be x plus 1 times x minus 2, which means if I were to add or subtract these, this would have to have an x minus 2 involved, and this one would have to have an x plus 1 involved, okay? So that's just how those would work. Now we're going to move on to the next page, and we're still practicing least common denominators with polynomials. Okay. So here's 7. We have x plus 5, x minus 5, and then x squared minus 25. So from here, it would help if we could factor x squared minus 25. Notice there is not a middle term there, but I do have two terms. So it either is a GCF, or the greatest common factor, or it is a difference of squares. And because this one does not have a singular x, that means it's a difference of squares. So if I were to factor this out, and we can use either x in box or our rule, we know we'd have negative 25 on top and 0 at the bottom. Okay, and we know negative 5 times 5 would give us negative 25, or negative 5 plus 5 will add to get us 0. Okay, so that means this becomes x plus 5, x minus 5 here. And notice that it's the same as the two previous. So we really don't have anything extra to add to. So it's just x plus 5, x minus 5. Okay. Now for number 8, we have 6 over x squared minus 4x, 2x over x minus 4, x minus 3 over x squared. Again, we're just looking for the least common denominator here. Notice the difference between x squared minus 4x and x squared minus 25 is this one has an x involved. So this one was a difference of squares. So I'll put DOS for difference of squares, whereas this one is a GCF, meaning there's a greatest common factor to take out. And that GCF between x squared and 4x is x. So that means what's left over would be x minus 4. I can always multiply or distribute the x into parentheses to check my answer. Then I still have x minus 4 and x squared. Okay, now remember they all have to have the same thing. So even though this has an x and this is x squared, I need to make sure that both or all three of my answers have an x squared involved. So this one has to have an x squared. And then the only thing missing from this x squared is the x minus 4. It's already included here, but this one has to have an x minus 4. Okay, now that we've practiced and gone over least common denominators, now let's apply this for adding and subtracting rational expressions that don't have the same like denominators. So first thing we're going to do, very similar to multiplying, dividing, is factor if necessary. Okay, so do we have a greatest common factor? Do we have difference of squares? Or do we have a trinomial where we draw the x in box? Once we get the common denominator, we're going to find the least common denominator and create equivalent fractions. Equivalent means equal. Then we're going to add and subtract the numerator, which is the top row of your fractions, and keep the denominators the same. So let's apply this to 9 and 10. Okay, so now we have 5 over 12x plus 7x minus 6, or divided by 6. And so we need to find the, if there is a GCF, we have to factor. Fortunately, there's nothing to factor here, so we're going to go on to our next step to get the common denominator. So our LCD here would be 12x. Okay, 12x. I know I can multiply this 6 by a 2x here, but I must do it to the top as well. I don't need to change 5 over 12x because it's already at its point. So now, once I've done that, I have 5 over 12x plus 14x squared, because x times x is x squared, all over 12x. Okay, and then we add our numerator. So we're going to keep our 12x at the bottom. Then we have 14x squared plus 5, or you can say 5 plus 14x squared. I'm not going to factor. There's no GCF to take out here. I'm not going to reduce anything because 14x squared plus 5 is together. So this is my simplified answer. So now we go on to number 10. We have factor if need be. Oh, these are already factored for us. So now we're going on to step 2, finding our least common denominator. And so I need to know that my least common denominator here is x minus 3 times x plus 4. So that means my first term, x minus 2 over x minus 3, needs to have an x plus 4 on the top and bottom. Okay, so I'm going to multiply top and bottom by x plus 4. And now on the other side, I know I need x minus 3, so I need to multiply this other side by x minus 3. So then when I have that, I have x minus 3, x plus 4. So then on the top, I have x minus 2 times x plus 4, plus on the other side, I'm multiplying by x minus 3, 2x times x minus 3. And remember, these have the same denominators. So all over x minus 3 times x plus 4. Now we're going to multiply our polynomials because when we're adding, we need to make sure that there's things that could cancel out here. Okay, we're not going to do it here, but we're going to do it for literally just across the top. So unlike multiplying and dividing, I do need to make sure that I expand my binomials. Okay, so if I do this, remember I can use FOIL or I can use the box method. I'm going to put it over here on my previous one. So I have x minus 2, x, and positive 4. Notice I'm multiplying here. X times x gives me x squared, negative 2x, 4 times x is 4x, and then I have negative 8. Okay, so I'm going to write this all out. Notice I can combine like terms if need be. So I'm going to do x squared minus 2x plus 4x minus 8. Then I know I can distribute 2x into parentheses for my other term. Big O plus sign, 2x squared minus 6x. Now I'm going to cancel out or combine my like terms. So I can combine x squared with 2x squared here, and it's positive, and I would get 3x squared. Then I have positive 4x minus 2x, which is 2x here, but then I have negative 6x on this side. And so if I were to do that with minus 6x, I get negative 4x combining those like terms. Then all I have left is negative 8 all over x minus 3, x plus 4. Now I'm going to simplify if need be. So I can draw the x in box here. So negative 24 over negative 4. Now we're going to see if there are any like terms. I'm using my calculator. So negative 24 divided by x, negative 24 divided by x plus x. Hit that second graph button. Now I'm looking for negative 4, and there isn't a negative 4, so there's nothing that I can combine to reduce this, so we're leaving this answer the way it is. If there's not negative 4 in that y2 column, that means this is cannot be simplified, so this will be my final answer. Okay, we have 3 more examples to go. Alrighty, number 11. Okay, remember we're trying to find the least common multiple for both of these. Notice we have a difference of squares here at the bottom. So this is really x plus 2, x minus 2, because the square root of 4 is 2, if you know your perfect squares. And so that means the only thing I need to include on this side for my least common multiple is x minus 2. And I must do that to the top and the bottom. I don't need to do anything to the other side because it already has an x plus 2. So now I have x plus 6 all over x plus 2, x minus 2, subtracting, distribute, I have 3x squared minus 6x all over the same answer. Now when I add or subtract, I need to distribute this negative 1 over to the other side. So distribute the negative. And when I distribute the negative, I get negative 3x squared plus 6x. Now I combine my like terms. There's nothing I combine with negative 3x squared, so I'm going to keep it here. Then I have x plus x, or 6x, which gives us 7x. And then I have plus 6 here. Okay. Now we need to see if I can factor my numerator. All right. Okay, so from here, I'm going to factor out my negative first. So that changes all the signs on the inside. So there's one way you can write your answer. And now I'm going to factor what's in parentheses. So in the top, 3 times negative 6 is negative 18. Then I have negative 7 on the bottom. Okay, go to my calculator. Looking for negative 7, and I have 2 and negative 9. Now I'm going to draw my box, and I have to draw the box because my a is greater than 1, so I must draw the box for this next part. First term is 3x squared. Last term is negative 6. Pardon the handwriting and lack of room. Then I'll put 2x here and negative 9x here. I take the GCF from the top row. The only thing I can take out between 3 and 2 is a 1. Outside of that, I can only take out an x. Then I know I need 3x on the top to make 3x squared. Then positive 2. And then down here, I know I need a negative 3. I can check my answers by multiplying back in. So then I keep my negative out front. 3x plus 2, x minus 3, all over, x plus 2, x minus 2. So you do have 3 answers depending on if you can simplify or not. Okay, on to number 12. I have x plus 1 over x minus 3 minus 5 over 3 minus x. Okay, so partially I'm going to rewrite this answer or this problem. So I have x plus 1 all over x minus 3 minus 5 all over negative, if I flip this around, it's negative x plus 3. And then if I factor out a negative, I would have x minus 3 in that parentheses. If you don't believe me, you can always distribute to check. So now I know they both have x minus 3. However, this negative 1 in the front is what changes this entire answer. So I need to know that my least common denominator needs to have negative 1. Okay, so I keep my x plus 1 over x minus 3 minus, now this becomes a negative 5 all over, negative times negative makes this positive, so x minus 3. Now I distribute my minus sign. So I have x plus 1 plus 5 because I multiply this part all over x minus 3. I combine my like terms. 1 plus 5 is 6. And here's my final answer because there's nothing else to factor. Okay, last example is 13. Okay, now we're going to factor the bottom part. Don't worry about the numerator just yet because we do have to add our like terms. So we are factoring really just the denominator for that first step. So x squared plus x minus 2. Now because this is a is just 1, I only need to draw the x here. And there's 3 terms. So from here, 1 times negative 2 is negative 2. We put the middle one at the bottom. We're going to find our 2 answers. And our 2 answers here will be 2 and negative 1. Okay. So now this changes to x plus 2, x minus 1. And look, this one already has an x minus 1 with it. So the only thing it needs is x plus 2. So our least common denominator here will be x plus 2. And I have to do that to the top and the bottom. So my entire answer here, I keep my 3x squared plus 6x plus 3, big minus sign here at the bottom of x plus 2, x minus 1. I'm going to do the whole things over x plus 2 over x minus 1, and I know I need to multiply these two together. So I'm going to draw a box on the side where I'm multiplying x plus 3, x plus 2. Now there's a difference between when I have to multiply and when I have to factor. Okay, so this becomes x squared, 3 times x is 3x, 2 times x is 2x, and then I have 6 in the bottom. So this is minus parentheses x squared plus 2x plus 3x plus 6 and close. Okay. So there's that first step. Remember, I went back, I factored first, found my least common denominator, and now once I know I have to multiply these two on the top, I made the box. Now my next step is to distribute this -1 before I can combine like terms. So 3x squared plus 6x plus 3 minus x squared minus 2x minus 3x minus 6. Now I can combine my like terms. 3x squared minus x squared is 2x squared. And then I have my x's. Okay, so I have 6x, and then if I combine -2 and -3, I get -5. So 6x minus 5x is 1x. Then I have 3 minus 6, which is -3. Now I'm going to factor. This is where we're going to factor 2x squared plus x minus 3 and see if we can simplify at the very end of this. Okay, so I'm going to draw x and box here. We're in 2 times -3, which is -6. Notice I have to draw the box because a is greater than 1. At the bottom I put 1. The two answers that I get, where they multiply to give me -6 but add to give me 1, is 3 and -2. So 3x and -2x. Now when I take the GCF of the top row of my box, it might be different depending on the order of where you put your factors. So I can only take out an x here, 2x, +3, and -1. So this changes to 2x plus 3 times x minus 1 all over x plus 2, x minus 1. And if you notice, my x minus 1's cancel. They create 1 because they're the same. And so I'm left with 2x plus 3 all over x plus 2. So as a recap, factor if need be, only for the denominator, find out what your least common denominator is, multiply if need be, distribute if you have a negative, combine your like terms, simplify. If needing to factor, you'll simplify again. So with this, please make sure you take your time, double check your answers, and have confidence. Thank you so much for watching this video.